Hello, my name is Riley Brown, and I'm the creator of the Point and Polygon Demonstrator. It is a Java-based program in order to demonstrate to computational geometry students how the Kirkpatrick method for determining whether points lie within a polygon. So the Kirkpatrick method was discovered in 1983 by David Kirkpatrick. It was described in a paper he wrote, and it has order n log n processing time in terms of the polygon, so if that we wish to query whether points are inside or outside of it, and it has order log n or logarithmic time query. So if we want to test if a point is inside or outside a already processed polygon, it will take log n time, in terms of where n is the number of vertices in the polygon. So to use the program, first we want to click in some points to create the polygon. So the points are going to be as ordered because we want to be able to do convex and concave. If you want to delete a point, you go to the closest, you get as close as possible to it, right click, and that will delete it, and it will continue inserting from the end. So let's go with this shape. As you can see, the program created a triangle around the polygon and triangulated the entire planar straight line graph. The Kirkpatrick method depends on making this triangulation in order to produce that logarithmic time query. So what we're going to use this for is the construction of a directed acyclical graph, which also known as the DAG, based on the triangles that are currently in and will be produced by later steps. So first, the first part of the DAG is just creating the bottom row with all the triangles from the first iteration of the algorithm. Now we will remove a maximal set of independent vertices. So usually we're going to start with the lowest number, not counting the outer points in the triangle, just the ones in the polygon. We're going to remove the maximal independent set of those vertices as such. So we remove 5, 7, 9, and 11. So 10 and 6 and 4 had some sort of dependency on one of those points, so we were unable to remove them. And then we retriangulated accordingly. And as you can see, it created, and this is a rather complex DAG because this is a complex polygon, but our program will draw lines to the triangles in our first iteration for which any one of these triangles overlaps with it. So as we can keep hitting the continue button, it will create more iterations. As you can see, now we're down to there. And so as you can see, we have 3 in this current iteration. If a triangle already existed in a previous iteration, we don't add a new node into the DAG. As you can see, so we add them. And finally, the last iteration, followed by the 1, 2, 3 grand triangle. So now we get to the point where we can query points whether they are inside or outside of the polygon. So as you can see, our little indicator here tells us that this pointer is not in the polygon because it first checks whether it is in 1, 2, 3. Then it goes down to the child of 1, 2, 3 that it is part of, which is 2, 3, 12, and then to 2, 6, 12, to 2, 4, 6, to 2, 4, 5. And we can check this history by using our left and right arrow keys, as you can see. And we can do these queries for any of these triangles, and it will return to us the triangle that it is within at the lowest level, which will highlight it green. As you see, yep, you can do that. Yeah, so then when we go back, we get our original shape, and that is how the Kirkpatrick method works. And as a, just sort of, in case we want to go through it again, it keeps the old DAG on here. But if I hit clear at any step, it will go back to the initialized state of the program, where there is no points on the left side and there's no DAG information on the right. I hope that was helpful in showing how to use the pointing polygon demonstrator, and hopefully this helps you understand the Kirkpatrick method.